Hello everyone. Good morning.
Hello.
Dear authors and invited guests, welcome to the technical session 2B. And myself, Srushti Rokde, and this session would be moderated by me. So, on behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the International Conference of Technological Intelligence and Business Strategists, TIBS 2026, Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held yesterday in Manila, Philippines, and the virtual event is being held through Zoom from today is 23rd and 24th of June 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. And I hope in this session we have like 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for questions and answers. On the 10th minute, I will give a gentle reminder for the presentation. Then there is another request to all the participants that you all have to stay connected with us till the closing remarks. And if you have any query or update, then you can write to me in the chat box. Just before we start the session, I would like to introduce our session chair, Mr. Sumit Kapoor, Dr. Sumit Kapoor, Associate Professor of and Deputy HOD of Computer Department, Computer Science and Engineering at Purnima University, India. With over 19 years of academic and research experience, he has contributed extensively to teaching, research, and academic leadership. His research focuses on agriculture, IoT, cybersecurity, and data privacy, and he actively publishes in reputed journals while serving as a reviewer and editor for various scientific publications. So, thank you so much, sir, for joining us.
Thank
So,
you, ma'am.
now we would start this session on a good note. So, now I would request our fourth author, Nuez Nguyen, to present their title paper. So, can you please share the screen, ma'am?
Yes. Good morning, all professor and teacher and participants. My name is Nunu Win from University of Computer Study, Tango. Today, I would like to talk about a hybrid bridge GRU architecture for Myanmar script video questioning. This is my content. In my essay, the European natural language description for visual content is a key test typing, computer vision, and natural language processing. This paper presents a multimodal video questioning framework for Myanmar script video questioning based on vision transformer encoder and encoded recurrent unit decoder. Global visual representation are derived from transformer-based text attention, while a class-prefixing mechanism is introduced to improve semantic grounding in a low-resource language setting. Experimental research evaluate using GLUE, PHRS, and CER metrics. In my introduction, video questioning combines visual context in natural language description. Vision transformer enable global attention by treating image as per sequence, set attention capture, language relationship between objects and sense elements. GRU decoders efficiently generate sequential testing one long dependency. My language talent has no experience with boundary, complex data structuring, and morphology. Subject-object-based structure in methodology, a specialized dataset comprise video frame image pair with corresponding demarcation and semantic class level to ensure class distribution, vocabulary size, data balance, and the linguistic complexity of the Myanmar script. A comprehensive statistical analysis of the complex is conducted. Vision transformer is used to extract visual data. The transformer-based encoding is superior to capturing language conceptual relationships based on standard convolutional data. Questions are processed using a comprehensive tokenizer that handles unique data stacking and on-demand script. To migrate the risk of hallucination and improve the relevance of the generated that instruction is augmented with corresponding class level using a structured token format. Questioning model accepts both image and text input simultaneously. The Visual Branch project the high dimensional bit feature brought a drawout layer and advanced layer to align them with the textual embedding state. Simultaneously, the test process, the encoder subunity control the embedding layer followed by a GRU. We implement the additive integration strategy to synthesize the visual feature from the bit at the linguistic feature from the GRU. This is the overview of the hybrid remastered video captioning model. The captioning model implies a dual input architecture. The visual brain project this feature to draw out and dance layer, while the textual brain process encodes the section sequence using an embedding layer and data required beneath. The GRU is selected for its parameter efficiently and successful sequence modeling in low resource setting. Visual and textual embedding are used for additive integration, promoting balanced multimodal contribution stable optimization. This representation is cluster fully connected layer and somewhat classifier optimized by categorical cost entropy loss and the advanced optimizer. In the dataset, the experimental evaluation was conducted on a dataset comprising simply source video category in 5 thematic class: anime, family, food, music, and sport. Following this pre-processing stage, a comprehensive metadata CP file was generated and synthesized, each extracting frames from its corresponding class level and a descriptive natural language caption. This process results a total of 765 image samples used for training and evaluation, with the distribution including 178 frames for anime, 168 for family, 172 for 172 for food, 110 for music, and 137 for sport. In training coverage analysis, all experimental was conducted using an end-to-end training paradigm for 300 efforts, employing a vision transformer as the video encoder and GRU-based decoder for caption generation. Beyond efforts 100, training accuracy consistently exceeds 80%, eventually stability above 92% after effort 118. The loss value coverage towards a narrow rate nearly 0.15 to 0.30, suggesting that the model reached a stable optimum. Although training accuracy reached approximately 95% at later effort, this behavior is expected in low resource captioning text and does not necessarily imply overfitting. The model performance was evaluated using Blue CHRS and TER, which together provide a comprehensive assessment of caption quality as well data and active distance level. The model achieved an average Blue score of 12.37, the average CHRS score of 50.37, and the average TER score of 74.86. The performance of the training model was evaluated through qualitative inference tests, and the model accurately identified both the primary subject and their activity within the visual context. For an input frame displaying a person with a musical instrument, the model generates the following descriptive section. English translation: A young man is observed playing a guitar inside a room. In Myanmar translation: ဂီတာတစ်လုံးနဲ့အတူအခန်းထဲမှာတီးခတ်ဖျော်ဖြေနေတဲ့လူငယ်တစ်ဦးကိုတွေ့ရတယ်။ This result demonstrates the model ability to efficiently bridge visual feature and with coherent natural language sequence in the target language. The experimental results highlight several important observations regarding the proposed architecture. The use of vision transformer feature plays a critical role in captioning global sense semantic. This representation encodes long-range dependency. The semantic class conditioning strategy significantly contributes to caption relevance, and this mechanism reduce ambiguity and construct the hypothesis space, which is especially effective in low resource settings. And GRU-based decoder demonstrates that sequence modeling capability with fewer parameters compared to LSTM-based alternatives. GRU offer an effective trade-off between expressive word powers and training stability for Myanmar language generation. And the adaptive teaching strategy between visual and text embedding ensure balanced multimodal contribution with design choice support stable and optimization. In limitation and implication, limitations are primarily attributed to the small dataset size, restrict vocabulary coverage, and lack of large-scale Myanmar pre-trained resources. However, the results demonstrate that meaningful video captioning in Myanmar language is possible even under constrained data coordination. Let me conclude my presentation. This study presents a multimodal video captioning framework for Myanmar language using a vision transformer encoder and a GRU-based decoder. Experimental results demonstrate stable training coverage and meaningful semantic learning. Evaluation using fluid THRS and TER metrics indicate strong level similarity and access level semantic consistency. So the proposed is GRU model establish a strong baseline for Myanmar video questioning. In future where the proposed framework provides a strong baseline and can be further enhanced through the larger dataset, text decoding, pre-trained multilingual language model, and temporal feature aggregation across video frames. Future work will explore temporal modeling, advanced decoding strategy, and larger datasets to feature improve session fluency and generation. Thank you, teacher.
Thank you. Uh, Thank you, Ms. Nave. I have a query.
Yes, teacher.
In a title, you have mentioned a hybrid VIT GIU architecture. Then my query is that why you use VIT over CNN? Why you are not using CNN based architecture for feature extraction?
Vision Vision transformer capture global contextual information more efficiently than traditional CNN, which mainly focus on local feature. This improves visual feature extraction for video frame.
And one another query is that you are using GRU architecture, but LSTM is also there.
The GRU require fewer parameter.
What is the
Train
advantage?
train faster.
Listen first. What is the advantage of GRU over LSTM?
Fewer parameter and training faster.
What parameters like? Can you explain? Can you explain the parameters by the using of GRU in the place of LSTM?
Uh, update and reset.
Pardon, please.
Update and reset.
Attach analysis. Okay. The last query, dear.
Yes.
You are taking the sampling size approx 270 images, na? In your PPT, you represent. Can you show your PPT again? Sample size.
Sample size.
Yeah, sample size.
Image.
In presentation, you are making one PPT of sample size. It approx 271. Whether it's a real data?
765. Yes,
700.
yes,
From where you
yes.
collect this data?
This collected data from internet.
From internet. Resources are not mentioned there. Whether it is making by you or collecting by some resources.
Resource MSPD data sets and MSRPDD. Yes, yeah.
The data is making by you, not by some authenticated resources.
Oh, making by me.
Right. That one. Animal, family, food, music, sports, total. There is no authenticated resources, no?
What authenticate resource?
The 765 data, you are framing 765 data sets. Can you show me the resources of these data set? From where you collect the data? Is from Kaggle, is from any other authenticated
And human
repository?
face, human face and Gage.
Okay,
Yes.
thank you.
Thank you, Chia.
Thank you, ma'am.
So now I would like to invite the next participant or presenter for the paper, A Unified Perspective on Bias Detection and Fairness Auditing in Large Language Models. Uh, do we have Kaveti Nani Karthik, sir? Sir, can you please share your screen? So moving on with the next paper, Algorithmic Statistical Arbitrage, Walk Forward Machine Learning and Dynamic Risk Gating in Intraday Commodity FX Market. Do we have the author Mohit Apte with us?
Yes, yes. I'll share my
Sure.
screen. So hello everyone, respected session chairs and other fellow researchers. I'm Mohit Apte. I'm presenting this from the University of Chicago. My paper's title is Algorithmic Statistical Arbitrage, Walk Forward Machine Learning and Dynamic Risk Gating in Intraday Commodity and FX Markets. Let's start with the economic linkage behind this research paper. We know that certain countries who are huge exporters, their commodity prices affect their currency as well, but there's a slight lag. And this paper is trying to capitalize and make a trading strategy, a pairs trading strategy between the commodity prices and the currency prices using the CME commodity futures and the FX futures. And I'll talk a little bit later in detail about co-integration. Co-integration is finding out whether these two assets or these two prices moving together have a stable, long-term, mean reverting relationship between them. The data set used is from Data Bento under the University of Chicago subscription for both the commodity and the currency futures, and they are hourly. The frequency is hourly. So these are the currency commodity pairs that are being used in the paper. The duration for which we ran this was 10 years, 2016 to 2026. So you can take a look, Canadian dollar, copper, Australian dollar, copper, Indian rupee, gold, things like that. So we did kind of two strategies. One was a very simple strategy, that is a Z score. We take the spread between the commodity and the currency, the log spread, and then we standardize it with a z-score and have a very simple strategy. When it is below negative 1.5, we enter the trade in a long position because we know it's going to mean revert. And if it's greater than 1.5, we go in a short position, and between that we do nothing, we hold nothing. This is a simple, some people call it a dead band hysteresis. Um, Now I want to be clear here. I have shown minus 1.5 and plus 1.5 here for illustration, but the actual values are changed from pair to pair, strictly decided using in-sample data and tested on out-sample data, out-of-sample data, uh, different entering and exiting positions for different pairs. Now I want to spend some time talking about co-integration. So correlation asks a question that whether two assets are moving together within the same direction. Co-integration asks a different question. It asks whether two assets have a stable long-term relationship or is it just a random walk. So what it would do is it would regress between the two assets and then it will subtract them yt minus beta times x, and whatever residuals are left, we will check whether that time series is stationary, whether its variance is stable and does not grow over time. So what we found is full sample over the whole 10 years, co-integration tests, that is the statistical tests with a significance value of the p-value at 5%, they test fails for all pairs, but it holds specifically in certain periods, certain regions, is what we observed. So once we found that out, what we did is we added almost like a gate. Every single time there's a stable region, we will set RT as 1, and we will have the full signal that we usually get. And during every unstable region, we'll set RT as 0, and therefore it gets multiplied by zero point 0.5, and therefore the signal uh, gets divided by half. So it's almost like a partial gate which stays open when it is a stable region and closes when it isn't. Now, I also tried another strategy that was the ridge regression. And this is a strictly walk forward strategy. In our back test, we train on 756 days, we test on 5 days, and we keep moving forward, pushing the window ahead. And this is strictly so that every single prediction is out of sample. We don't use future data to make predictions. And so that is the reason for that. If I could talk a little bit about the features, these are all the features related to the spread itself, the changes in the spread, relative strength index, the correlation between the two asset returns. The volatility regime is like a ratio of the short term volatility of the past few months versus the long term volatility of the like maybe 1 or 2 years. Now, contango single signal is an important feature. What it's a futures contract related issue where sometimes front month futures can be priced lower than the ones up ahead. That is contango. But if it's the other way around, it's backwardation. And that term structure needs to be understood by our model if it wants to predict returns, because at the end of the day we're predicting returns, and we're predicting what the spread value will be like and using that to trade. So these are the ridge coefficients that I found out. Now, of course, once we have signals, we need to actually back test our strategy, right? We have to go back from 2016 and actually see how it performs over time. So, how would we allocate capital for each pair? We have a bunch of pairs, right? We can't have an equal capital allocation. Some pairs are more risky than others, more volatile than others. One method is VAR-based sizing, so each pair gets equal risk allocation, right? So we calculate the value at risk using the 20-day historical returns and make it match the capital allocation. Now, PCA based sizing is a slightly advanced technique. What we do is we take the covariance matrix of the spreads of each pair. So what this takes into account two things. One, the variance itself of the pair itself, but also its covariance with respect to other pairs when we calculate the volatility of the total portfolio. And the reason we do a principal component analysis is to denoise the covariance matrix, because if we get the first few principal components that explain like 90% of the variance, we know the common factors affecting all pairs, and we kind of remove the idiosyncratic noise from the covariance matrix. And in the back testing, there were two modes. One was an academic mode where we do not consider any transaction costs, slippage. We do not allow, we allow fractional contract sizes, which is not possible in the real world. You can't buy fractional contracts. But then in the real world mode, we included slippage. We had margin constraints, right? So whenever you buy an actual contract on CME, there's a margin. When you have a roll over to the next contract, we have considered that in our PNL. This, as a side note, is the Optuna hyperparameter tuning, which I spoke a little bit about earlier, the entering and exiting for the fundamental strategy out of sample. So what we found in our final performance, the simple fundamental strategy has a Sharpe ratio, and Sharpe is just return risk adjusted return. It's just return divided by risk is 5.56. Now maximum drawdown was 23%. What's interesting is once we added that co-integration gating, although the Sharpe slightly improved, what was more surprising is that our maximum drawdown halved almost. So it implies that co-integration gating is a good risk measuring and reducing technique, because our risk is reduced. ML outperformed the fundamental strategy because it is taking in more features. It is a more advanced strategy, but it also tends to have a larger risk. And the PCA, in fact, increased our Sharpe, but also increased our risk in the maximum drawdown. And these are the equity curves, the drawdown curves of the various signals. And I think I just spoke about the conclusion right now. Performance varies by sharply by pair, yes. So some pairs make a lot of money where we were right. We knew that this has a stable long-term relationship and it did, but maybe a few pairs didn't do as well, which is I think sort of expected when you're doing a true back test out of sample. And that's it. Thank you so much.
Thank you, dear.
Thank you, sir.
Mohit, your data set is very wonderful. You work on the real data set. It's good. Many
Hmm.
few researchers are work on the real data set. Otherwise, all are make the anonymous data. It's work on anonymous data set. So,
Hmm. Hmm, hmm.
firstly, it's good that you are working on the real data set. In your
Yes.
presentation, you have mentioned one thing that you are using I think PCA ERC principle. Am I right?
Yes. 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 Yes.
Yeah. So, any advantage of this? Why you selected this one?
So this actually, the professor I was working with suggested me this. Basically, a covariance matrix is very, very noisy in general when we
Mhm.
observe for any asset. So what PCA does is it picks the eigenvectors and eigenvalues which explain most of the variance. So we know the common factors that are affecting all the pairs, but then that's why we extract those from the covariance matrix and we ignore the idiosyncratic individual noise of each of the pairs. So that is why I chose PCA.
And one more point is there. Side by side, you are also using value at risk (VAR) for the primary
Yes,
risk
yes,
measurement. Then
yes.
why you does not use CVAR? CVR is used
That's a
best
good
for the
point. That's a good point.
for the
Yes.
shortfall. Why you not selecting CVR? I think you
Yeah,
got a
that's a
better
good
result
point. That's a good
in the
point. Yeah,
place of
no.
VAR. है ना? Any
That
reason?
yeah, yeah. I chose VAR, but I didn't test with CVAR. But yes, expected shortfall is also something that is, I think, better than value at risk in this
अच्छा,
case. Yeah, I agree.
one more question. While you are working on the real data, you are facing some challenges. Like
Hmm.
sometimes there is a issue for completing the missing data, market holidays, asynchronous trading hours. How are you completing
Hmm.
this? When
So,
working on the real data is a main challenge.
So for CME futures, there's fixed trading days and fixed trading hours. So all the data set that is on Data Bento, the provider, it is
Uh,
being cleaned already and only for those trading days. And we've
uh,
included that in our strategy. So Saturdays and Sundays or some specific days when it isn't trading, then we exclude that during our
it
training.
means the data which you got as a clean data. Am I right?
Yes, yes, it is cleaned.
That's
Yes.
okay. Because when you're working on the real data, is the major issue. How you complete
Yeah.
the missing days, holidays, and synchronous
Hmm.
trading hours. Sometimes fluctuations also there,
Yeah.
you
Yeah.
know,
Yeah.
for any news.
Yeah.
Okay, good. Last question, from my side. How do you
Yes.
prevent look ahead bias and data leakage during the model training?
Yes. So the walk forward ridge regression is the primary method by which I
Good.
stop the look ahead bias, because I train on the past window. I calculate the signal for 5 days and I move 5 days every single time and retrain. That's how we avoid look ahead bias.
Uh, After each 5 days, you retain the system.
Yes, yes, it is retrained every 5 days.
That's it, give the correct answer. No? Otherwise, if you not retain the system in the sequential mode, then the output is not perfect.
Yeah, yeah, that's true. Yeah.
Okay. Thank you. Thank you so much.
All right. Thank you so much, Professor.
Uh, Thank you so much, Mohit. So now we would move to the next paper. So the paper title, Intelligent Synergies, How AI Systems, Big Data Analytics, IoT, and E-procurement drive sustainable supply chain performance through the mediating role of supply chain resilience. So do we have the presenter Rajia Sultana with us?
Yes, I'm present.
Over to you.
Okay, thank you.
लगता है सभी लोग इन
Hello, everyone. Um, Good morning. I'm Rajia Sultana, one of the author of this paper. So now I would like to present our paper titled Intelligence Synergies, How AI Systems, Big Data Analytics, IoT, and procurement drive e-procurement drive sustainable supply chain performance through the mediating role of supply chain resilience. So now coming to the context, in this recent years, supply chain vulnerabilities are increasing worldwide because of pandemics, geopolitical conflicts, and other reasons. And this is why sustainable supply chain performance has become one of the most strategic priority to the stakeholders and the customers. So why this matters? Though firms are investing in digital technologies, still struggle to achieve the sustainable supply chain outcomes because of the disruptions. And as most empirical evidence comes from the developed economies, so there is a gap here for the developing economies like Bangladesh. The core problem, only adoption of digital technologies cannot improve the sustainable supply chain performance. There, as it should be integrated, there should be integrated the framework combining multiple digital technologies is largely absent in terms of the Bangladeshi context. The proposed solutions of this paper is to analyze the influence of digital technologies on the sustainable supply chain performance. Here is our conceptual framework. Um, there are two theories are used here. The first one is resource-based view, where it shows that AI systems, big data analytics, IoT, and e-procurement are considered as the valuable resources and capabilities which can improve the competitive advantage. And the second one is dynamic capabilities theory, where it shows that supply chain resilience can help to adapt the firm to in the changing environments. Let's come to the literature review. Supply chain resilience has become the key indicator of the long-term organizational success, which can integrate the economic, environmental, and social objectives. AI systems help to decision making through the learning, prediction, and problem solving capabilities. Also, it supports the circular economic practices through the waste reduction and process optimization, and enhances the supply chain adaptability. Big data analytics helps to transform the large set of data into actionable insights, which can help to improve the evidence-based decision-making process. Internet of Things helps in real-time monitoring and information sharing across the supply chains. Also,
it strengthens the supplier integrity, customer connectivity. E-procurement helps in digitize the procurement and sourcing systems. Also, it enhances the transparency and coordination among the supply chain partners. Supply chain resilience helps to anticipate and respond and recover from the disruptions. At the same time, it strengthens the business community, competitiveness, and advantage. Here are all the hypotheses. So now moving to the methodology, primary data was collected from the primary data was collected to examine the technologies on.
Yes.
Sorry.
Share your screen.
It is already shared.
Great. Okay, now visible.
Okay. Primary data was collected to examine the effects of digital technologies on sustainable supply chain performance. And here we have used the quantitative design. Targeted populations, we are collected the responses from the employees who are already working in the manufacturing industries in Bangladesh. For the survey instrument, we have used the structured questionnaire and the 5-point Likert scale. Survey distribution was conducted through the Google Forms and social media. We have used the non-probability purposive sampling because of we need the responses from those who have already knowledge about the sustainable business operations. About 307 responses were collected. And for the data analytics, we have used the SPSS for descriptive statistics and Smart PLS for the measurement and structural model testing. So this is the result. So here, factor loading, CR and ABE all are exceeded the threshold level. This is the result of discriminant validity, where all the values are less than the diagonal value. So among all the hypotheses, four are accepted in terms of direct relationships and one is rejected. And in terms of indirect relationships, 2 are accepted and 2 hypotheses are rejected. This is the result of the discussion part. So AI systems helps to enhance the sustainable supply chain performance by decision making and analyzing the process automation. Also, it helps to strengthen the adaptive capability in terms of the mediating system. Big data analytics helps to improve the sustainable supply chain performance by data-driven visibility. Also, this is not that significant in terms of the economics like Bangladesh due to the delayed integration. IoT helps to strengthen the sustainable supply chain performance by real-time tracking and resource monitoring. Also, this helps to enable the rapid sensing and response to operational disruptions. If procurement, neither this is significant in terms of direct nor the indirect relationships due to the insufficient complementary supports from the collaboration, green purchasing, and other reasons. Supply chain resilience is significant in terms of direct relationships, which can help to enhance the redundancy and recovery capabilities. So now coming to the practical implications. So firms and organizations should prioritize the investment in digital technologies to gain the sustainable supply chain performance. Also, it can maximize the benefits in the long term. Policy implications. Strong digital infrastructure and institutional support are necessary for the effectiveness of implementation in the e-procurement system and other systems. And policymakers and government should investment more in the digital education and workforce development, so that firms can achieve the organizational competitiveness in the long run. Overall, AI systems and Internet of Things improve the sustainable supply chain performance. Also, digital transformation is necessary for the long-term competitiveness and effectiveness. Further limitations and future research direction. In our paper, we have used the cross-sectional and self-reported data. For the further studies, longitudinal data can be used, and this framework can be tested in other developing emerging economies. So that's all from me. Thank you.
Thank you, Ms. Rajia. Rajia, I have a question.
Yes, please.
The first question, are you the real author of this paper or just a speaker?
Yes, sir. I'm a real author. I'm one of the
You're a real
authors.
author. You are one of the author?
Yes, sir.
Okay. Now tell me one thing, you are using AI, big data, IoT, e-procurement. Can you explain which one is the strongest impact on supply chain among all these?
Okay. Let me share the results. So from the analysis part, we can say that the AI system and the Internet of Things, both of them has the strongest impact on the supply chain resilience in terms of the Bangladeshi context.
AI and big data analytics. These two?
AI system and Internet of Things.
AI system and IoT,
As
Internet
both
of
of
Things.
them are both of them has the direct and indirect relationships with the sustainable supply chain resilience performance.
Okay. The other one question is that how you validate the mediating role? How you validate the mediating role of supply chain resilience?
Sorry, sir.
My question is that how you validate the mediating role that you mentioned through the mediating role of supply chain. My question is that how you do this? In the title, you are mentioned how AI, big data analytics, IoT, e-procurement device, supply chain performance through the mediating role of supply chain resilience.
Okay,
My
sir.
query is that how you validate this?
Actually, we have literature reviewed that supply chain resilience can be a variable which can enhance the sustainable supply chain performance. So we tried to sort out is this help to mediate the relationship between the dependent and independent variables. So that was our one of the objectives in this paper.
Okay.
So we tried to sort out.
Try to sort out. Okay.
Yes,
could you emerging technologies such as generative AI, digital twin for further enhance the system? Could you use these technology?
sir,
like digital
these
twin
technologies are used in the manufacturing industries.
in the
This is why
manufacturing
we collected the responses from the manufacturing industries of Bangladesh.
Okay. You are collecting the data from Google Form through the
Yes,
Google
sir.
Form. Am I right?
Yes, sir.
So which age group you focus?
Sir, this is from age group of 25 to more than 50 plus.
25 to more than 50. And what are
Yes,
the
sir.
how many parameters are there in the Google Form which you collect by which you collect the data? Can you tell me the parameters?
Sir, we collected the data through the Google Forms, and there are we use the different items from which are adapting from the existing papers, existing literature reviews.
How many questions are there in the Google Form?
Sir, about 28 items were there. We
More
could
than
not
28.
accepted all of them because of the low values. Some of the some of the items has the low values, so which has the strongest values, we only accepted those items.
So out of 28, I think we are working on only 12 or 13 parameters, which
No, sir.
give the good values.
About 24 items were accepted because of the loading values.
Okay. My last question is that how does the framework perform during the measure, like say disruption or pandemic or disaster? Sometimes these things are occurs, na, like COVID occurs. So can you explain the system also work on this?
So,
If
sorry,
the
sir, can you
pandemic
please
occur,
repeat? Yes,
if
sir.
the pandemic occur, like a natural disaster, like any geopolitical crisis, then the whatever system you design, whatever data you collect, can you also consider these sustain?
Sir, hopefully, sir, we will take care of it. We will next investigate this. So at this
Right
moment, sir,
now,
I cannot
this time
share.
this time you took only positive data.
Yes, sir.
है ना?
Yes,
Okay.
sir.
And is the data collected from your university college or somewhere outside also in Bangladesh?
Sir, we have implemented this in Bangladeshi context. So this framework can be used in other economies. So this can be the
Hmm.
next research options.
That's such options. Okay. Thank you.
Thank you.
Thank you,
Thank you,
Razia.
sir.
Thank you so much, Razia. So we would now move on to the next paper. Myanmar news classification using Ember Graph Sage. So do we have the presenter Sue Tun with us? Myanmar news classification using Ember Graph Sage. Do we have any consecutive author of the same paper? They can also present the paper.
Hello? Hello?
Hello.
Yes, ma'am.
Hello?
Hello.
Okay.
Yeah, audible.
Okay, can you hear me, sir?
Yeah, audible. What's your name?
My name is Suseton, sir.
Okay.
You can see my page, sir.
Yeah,
My screen.
visible. Your skin
Okay,
is
thank
visible.
you. Okay, teacher. Okay. Good morning, respected chair and everyone. My name is Suseton and my supervisor is teacher Mo. I am from Myanmar, Pilno. Today I am going to present my topics on Myanmar news classification using MPAT graph set with compare different word embedding technique to improve Myanmar news classification. Okay, next is content for my presentation. In my content, abstract nature of Myanmar language, data collection, methodology, experiments, and collection. In my abstract, text classification has become a crucial step in natural language processing, especially for low-resource language in which limited annotated data and linguistic resource remaining main challenge. This work present inductive graph-based approach, graph say, graph symbol, and aggregator for next classification, applying different word embedding model for Myanmar news classification. Experiments are conducted on 8 Myanmar news category: business, crime, culture and tourism, education and technology, entertainment, health, politics, and support. Hello, sir. Can you hear me?
Hello. Ma'am, I am hearing you, but your slides are not movable. Can you change your slides also? Only initial slides visible.
Now?
Right now. Now, okay.
Okay. Okay. I
Hmm.
say again my abstract. Text
Yeah.
classification has become a precious text in natural language processing, especially for low resource Myanmar language in which limited annotated data and linguistic resources remain main challenges. This work presents inductive graph-based approach, GraphSig, using symbol and aggregate for text classification, applying different word embedding model for Myanmar news classification. Experiments are conducted on 8 Myanmar news category: business, crime, culture and tourism, education and technology, entertainment, health, politics and support. The experiments show the effectiveness of BiLSTM, bidirectional long short-term memory, and graphic architecture integrated with traditional and contextual embedding methods, including TF-IDF, time frequency inverse, document frequently. Nyambata and embed multilingual bidirectional encoder representation from transformer. The performance of graphics model is compared to sequential deep learning technique based on BiLSTM. Experimental results reveal that graph-based approaches achieve better performance than BiLSTM-based model in all embedding settings. Among the evaluation model, embedded with GraphSay get the highest classification accuracy of 63%, followed by Nyambeta with GraphSay with 60%. In contrast, Nyambeta with BiLSTM and Embeta with BiLSTM yield 47% and 52% accuracy, respectively, whereas TF-IDF with GraphSay obtained 57% accuracy. The findings show that combining the contextual transformer embedding with graph neural network substantially enhanced text classification performed by efficiently modeling semantics and relational information. Now, let's move to the next slide. Nature of Myanmar language. Myanmar language is an official language of Myanmar and it is also known as Burmese. It belongs to Tibeto-Burman branch of Sino-Tibetan language family. Myanmar characters have three groups: consonant known as P, middle known as Bidwe, and vowel known as Tara. In Myanmar script, there are 33 basic consonants, 4 basic medial, and 6 combining medial. A Myanmar text comprises of a sequence of characters with no word boundary makeup. It is written from left to right and it does not use space between words. While space may separate phrases or sentences, it is necessary to perform word segmentation. In my next slide is data collection and data preprocessing. In well-resourced language, there are many freely available datasets online. However, low-resource language such as Myanmar language, there are not many freely available datasets. In this study, Myanmar news data were collected from numerous online resources. For example, Myanmar Digital News, the Myanmar Portal, Myanmar Radio and television like Myanmar TV News and Hugging Face. As shown in figure, the data set and its content of 8 different predefined categories: business, crime, culture and tourism, education and technology, entertainment, health, politics, and support. In this slide, there are 26,347 documents in total we use as shown in figure. Each category contributes 12.5% of total data set.
Okay.
The data collection of data preprocessing. The data preprocessing phase consists of two major tasks: relevant characters are eliminated, word boundary and are identified, remove relevant character usually involve eliminated non-Myanmar character, number, special symbols, and extra white space within each sentence. Data preprocessing phase consists of two major texts. Relevant characters are eliminated, two word boundaries are identified. Removing relevant character usually involve eliminating non-Myanmar character, number, special symbol, and extra white space with each sentence. Here is example for my data preprocessing. The next is methodology. GraphSay is a widely used graph neural network approach development for inductive representing running on graph structure data. Unlike traditional embedding method that assign unique embedding to each node, GraphSay generate embedding by assembling and aggregation information for a neighboring node. This enables the model to generalize to unseen node and large dynamic graph efficiently. The framework supports different aggregation functions such as mean, pooling, and LSTM aggregator to capture neighborhood information effectively. GraphSeed can work well for text classification, especially when your data are relationship between document, word, users, citation, or label. This table is shown on training data and testing data statistics, in which testing set is 24,000 and test set is 2,645 documents we use. 2 by LSTM model-based experimental pattern training with pre-trained M data and M beta and embedding and hyperparameter used for bi-LSTM training is shown in figure. In our research, in GraphSafe training, 3 experiments are done regarding GraphSafe. My first experiment combining TF-IDF with GraphSafe. My second experiment combining M-Beta with GraphSafe. My third experiment combining M-Beta with GraphSafe. Embed is a multilingual transformer model trained on over 100 languages for general across language natural language processing test. Yambeta is a Yama-specific transformer model optimized for Burmese language understanding text such as a text classification, name entity, recognizing, and sentiment analysis. The hyperparameter used for graph size training and are shown in this table. This chart compares the classification accuracy of 5 different models in which lowest accuracy was achieved by Nyambeta plus by LSTN with approximately 47% and the best performance Nyambeta and Grubs say.
Excuse me, ma'am. Sorry to interrupt, but 11 minutes have passed. Could you please move on faster?
Okay, teacher. Okay, teacher. The model combining with graph 6 inconsistent outer performance those integrate with BiLSTM. The lowest performance was obtained by Nyambet A and BiLSTM with 47%, whereas Embed with graph 6 got to highest accuracy of 63%. This showed that the graph 6 representation learning achieved better result than sequential modeling for the test classification test. The result highlight that embed consistently outperform Embed is both architecture. One possible reason is that Embed takes advantages of large-scale multilingual pre-train and it allows the learning more comprehensive semantic presentation. Embed E, while specifically tailored for Myanmar language, may impact for limited pre-trained resource or dataset. The result recommend in integration by multilingual content embedding with graph neural network offer a more robust technique for getting better classification performance. This table shows experimental result and decision in which higher accuracy is 0.63 and the best performer is support for 0.82 F1 score and the lower performance is culture and tourism. F1 score is 0.30. The experimental result and in general, the results show that combine graph-safe with embed enhance contextual representation and graph-based relational learning for Myanmar news classification. Nevertheless, the performance variant across the category specific that one class still suffer from semantics overlap and highlights opportunity for future enhancements our improved graph structure and domain-specific feature. Let me conclude my presentation. In this work, the performance comparison between deep learning model and graph-based model has been conducted by applying traditional feature representation technique, TF-IDF, and different word embedding model, Embed and Embed. TF-IDF integrate with graph-safe already achieve better performance than ILSTM-based approach. Show the benefit of graph-based modeling for this text. The neural network the neural language meta embed consequently outperform Embed show improved generalization from multilingual pre-train in this form. A graph-safe result is better accuracy than by LSTM-based model across both embedding type and it confirms the graph neural network and more effective at representation structure or relation information in the data. The best performance is achieved by using Embed with graph-safe 63% accuracy. It's indicated that integration of strong multilingual embedding with graph-based learning obtain the most of robust performance. In future, 5-Zoom language model and graph encoder are joint applied in the end-to-end manner and it can better align textual and structure information and improve overall model integration in comparison to train them separately. Thank you.
Thank you, ma'am.
Sir.
Thank you, ma'am. Question
Yes,
from my
sir.
side. The first one is that why
Please,
did you
sir.
choose Myanmar news classification as a target application? The basic
Because
question
yes, sir.
is a basic question. Why did you choose the Myanmar news classification as a target application?
Because Myanmar, I choose Myanmar news classification because Myanmar data set is very limited.
Okay.
So
Another question. Okay, I
yes, sir.
understand. Another question. And
Yes, sir.
what are the challenges did you encounter during the study?
This is a challenging my computer. Please, sir, I can't hear. Please repeat
Ma'am, what are
again.
the challenges you encountered during the research? When you work on the Myanmar news classification, some challenges
Yes.
you face. Can you explain these challenges?
Yes, this is challenges because Myanmar is not expertly data set, and also Myanmar sentence is not using space for word segmentation, so not word binary defier. So that is challenges for me.
Okay, you are using graph says
Yes,
selected
sir.
over traditional text classification model. Why you are not using GCN and GET? While GCN is a very most popular and much better than the graph says.
Because I use graphics because a traditional GCN is transitive learning. It is no relation other node, but graphic is no very well aggregated neighbor information, whereas traditional method usually require retrain when new node is added. Graphics is more efficiency than traditional GCCN.
Okay. Ma'am, did you plan to integrate conceptual embedding such as embed, XLMR? Are you heard XLMR or not?
Yes, sir, please. I
XLM.
can hear very well, sir. Yes.
You heard? You are hearing XLM? XLM in the conceptual embedding. Whether you integrate this or not. Right. Okay, last
This
question
is
from my
a
side.
little connection problem. Okay,
Okay,
okay. Oh, yes, sir.
last question from my side. Just wait.
Contextual.
You are
Okay,
using
okay, okay.
26,645 documents. Am I right?
Yes, sir.
In the
Yes, sir.
presentation, you are studying 26,645 documents across
Yes,
8
sir.
categories.
Yes, sir.
On which ground you categorize these?
I categorize Myanmar news, Hugging Face, and our Myanmar portal news.
Okay. How you filter the duplicate data?
No, sir.
How you filter out the duplicate data? Okay,
Duplicate
thank you.
data. Okay, okay.
How you filter out? Okay, thank you.
I can hear very well, sir.
Yes, give the answer. I have a simple question. How you filter out the duplicate data?
Duplicate data.
How you filter out? How you
Of a
remove the
filter.
duplicate data?
You mean
Yes,
filter?
yes, filter.
Or duplicate? Or how filter? Or I filter my duplicated data for with a starfish method, sir.
Okay. Okay, ma'am. Thank you.
Okay, okay. Thank you, sir.
Thank you. Welcome.
Thank you, ma'am. So, I request the other upcoming presenter to keep their cameras on while presentation. And we have limit of 15 minutes for both question answer and presentation. So
Yes,
I
ma'am.
hope the presentation completes it
Sir,
within 12 minutes.
here
So,
is my camera is a little bit problem, sir.
okay, fine, ma'am.
Okay, okay. Thank you, sir.
So we have the next presentation for the paper titled Navigating Artificial Intelligence Integration in Business Organizations, a qualitative exploration of leadership strategies and employee adaptation by Randy Joy M. Venthayan. So, do we have him?
Yes, good morning, everyone. I hope I'm audible.
Yeah, you are audible, sir. Very good
Can
morning.
you hear me? Yes. I'm here to present to you the paper entitled Navigating Artificial Intelligence Integration in Business Organization. It's a qualitative exploration of leadership strategies and employees adoption. So with me is Dr. Edgar Q, Dr. Felix Pocong, Mr. Darwin Catalan, Dr. Santa Paltado, and Dr. Ethel Chua, and yours truly. Uh, uh, in this research, we examine the AI integration not only on technological development, but also as a leadership workplace challenge. In particular, is explores how leaders guide AI adoption and employees respond to adjust the changes in their daily work. For this presentation has followed the IMRAD. I briefly explained the background, research gap, and purpose of the study, and I will discuss the qualitative methodology and then present the major findings concerning leadership strategies, employees' challenges, adoption, effective leadership practices, and the implications and the recommendation. And the central of this study is that AI succeeds when technology is combined with trust, capacity building, and ethical leadership. So artificial intelligence is changing how business perform tasks, analyze information, communication with customers, and make decisions. However, introducing AI into organizations is not simply a matter of purchasing software or installing a new system. Leaders must also manage employees' uncertainties and resistance to change, skill gaps, and concern about job security. Although there are a lot of studies about AI in terms of productivity, automation, and operational efficiency, there are only few studies have explored the actual experiences of leaders and employees during the integration. And therefore, this study aimed to explore two important areas. The first one is how the business leader develop and implement strategies for AI integration, and the second one is how employees perceive and adapt to AI-driven workforce challenges. So this study employed a qualitative multi-case study design because the researchers want to understand the experiences, perception, and interpretation of people directly involved in AI integration. The participants includes the leaders, managers, team leaders, and employees from organizations that had already implemented or were currently implementing AI technologies. And purposive sampling were used and data gathered using semi-structured interview and analyzed using thematic analysis. And the researchers reviewed the interview transcript, developed codes, and organized recurring ideas into major themes. And for the first result, the first major finding showed that leaders generally approach AI integration as a phased, strategic, and capacity-oriented process. Instead of introducing AI throughout the entire organization at once, leaders commonly began and selected functions such as customer service, marketing, data analytics, and this gradual approach allowed the organization to test the technology, identify problems, and make improvement before wider implementation. And leaders also emphasize employee readiness and continuous training. They recognize that AI tools would not be effectively unless employees understand how to use them. And ethical governance was another major consideration, particularly in relation to privacy, security, transparency, and accountability, since we are giving information to the machine. And the organization often collaborated with technology providers or expert consultants and research institutions to gain expertise and reduce the implementation risks. And for the employee challenges, despite the potential benefits of the AI, employees experience several challenges. The first one is technological anxiety, especially on the part of marketing people or customer service. They fear that the AI could replace their jobs and reduce the need for human workers. And the second challenge involved the limited technical competence. Some employees lack sufficient digital skills, and others felt that the training provided was inadequate. And communication and collaboration issues were also reported, and some employees believed that AI reduced face-to-face interaction and created confusion when teams interpreted AI-generated information. And employees also experienced limited managerial support and change management practices. It might be because some of the leaders are not also expert in the use of artificial intelligence, especially when AI implementation was rushed or poorly explained. And concerns were raised regarding data privacy, security, and reliability of AI-generated decisions. So these findings show that employees cannot simply be expected to adjust without training, guidance, and participation, and of course, the trust. And for the employees' adoption occurred gradually. At the beginning, many employees felt overwhelmed, uncertain, and worried about the job security, as mentioned before. However, their attitude began to improve through training, experimentation, peer support, and practical experiences. And as employees become more familiar with artificial intelligence, they become using it to handle repetitive tasks, support decision-making, and improve productivity. So over time, some of the employees shifted from viewing AI as a possible replacement to their work, seeing it as they see it now as a collaborative tool that could enhance their capabilities. But however, successful adaptation depend heavily on organizational support, not only on employees. Employees adjusted more quickly when leaders provide clear communication, continuous upskilling, hands-on assistance, and opportunities to participate in AI-related decisions. And the findings also indicate that effective AI leadership combines several complementary practices. Transformational leadership provides employees with clear vision and explain how AI support the organization and professional development. Participative leadership involves employees in planning and implementation, which we're familiar with this already, which increases ownership and reduce resistance. Continuous capacity building that provides skills and confidence required to use AI technologies effectively. Transparent communication, which reduces uncertainty by openly explaining the goals, risks, limitation, and possible effects of artificial intelligence. And then support leadership provides both emotional and technical assistance during the transition. And of course, ethical leadership promotes fairness, privacy, accountability, and overall AI use. So AI integration should be understood as a social-technical transformation. The technology is really important, but leadership determines whether employees will give their trust, accept, and effectively use it. And lastly, however, successful and sustainable AI integration requires more than just technological investment. It requires alignment among technology, also with people or employees, organizational system, and leadership practices. So based on the findings presented a while ago, organizations should institutionalize continuous upskilling and reskilling programs, and leaders should communicate clearly about the purpose, the benefits, the possible risks, and limitations of the technology, specifically artificial intelligence. And employees should also be involved in planning and decision making to strengthen the ownership of its ownership and of course the acceptance. And the organization will also develop ethical governance and policies to protect privacy, promote fairness, and accountability. As a final takeaway, this study is as simple. Organizations should not merely install artificial intelligence, they must lead their people through the transformation. And that would be all. Thank you very much.
Thank you, sir. It's a really nice presentation. I have some questions. Hello.
Yes.
It's a wonderful presentation, firstly. My question is that which leadership strategy is found very effective in facilitating the AI adoption?
The most effective is when you have interview with the leaders, it's more on the upskilling of their employee, and something like they should, as a leader, they should be the one expert in the use of artificial intelligence, not only the employees, because they should be a good role model on the use of artificial intelligence.
Yeah, correct. The other question is that while implementing the AI, the first question comes in the employee mind that's related to job security. How the leaders balance technological innovation with the employee about their job security concern?
Yes, actually, that is the one of the major concern of of the employees, when especially on the part of marketing, on the
Yes.
part of sales, where we can do automation. Some of the employees are concerning about their security, but as of the moment, those questions are not yet fully answered by the leaders as of the moment, since this study is just initially, and it's just conducted in the Philippines, so we don't know the perspective of the whole world. So this is one of the limitation of this study that can be replicated in the future.
Because whenever the AI is introduced in the business or in any organization, the first point come in the mind of employee whether the job is secure or not.
For now,
Whether
they are
AI
secured.
whether AI replace the human
Yeah.
or not.
Yes,
Am I right?
yes. For now,
Okay.
but we don't know in the future.
Okay. What are the differences between manager and non-managerial employees while adopting AI?
Of course, for automation purposes and to the main purpose of business is to minimize the cost and maximize the profit. So this is the main purpose why we need to adopt artificial intelligence. So despite the leaders are not saying that they will lay off some of their employees, we don't know their plans because this study is limited when it comes to the adaptation, the challenges, but when it comes to their plans, we still don't know what will happen. Maybe in the future, we will
In
see
the
based
maybe
on
in future, it's a very contradict point. How it success, it's a contradict part. Okay, thank you.
yeah.
It's a good
Thank you
presentation.
very much.
Okay, thank you. Next, ma'am.
Thank you so much, sir. It was a great presentation. Moving on to the next presenter. So we have a paper towards safe AI, a four-layer survey of risk mitigation and alignment directives. So we have the presenter, Rushil Jariwala. Sir, are you in the
Please.
meeting? Rushil Jariwala. Any other author of the same paper can also present the paper. So
Hello.
we would just wait for 1 minute.
Okay.
We have one previously assigned paper too, because one was remaining. I would just call out his name. If he is in the meeting, we would conduct the presentation. I'm sorry, sir, I accidentally left the meeting. We would just have a picture with all the presenters we have in the session. Can every one of us switch on their camera? We would have a nice picture of as a memory of this session. Thank you so much, sir. So this was all about the presentation and the presenter of this session. So I sincerely thank our authors of for their excellent presentations and contribution for this in this session, and all the participants for being a part of this international conference. I hope this session was informative for all of us, and on behalf of the whole team, I thank you for the support during the virtual conference, and we will be happy to have you in the next session of 2027 too. So
Thank you so much, ma'am.
Uh, just a sec, sir. I would just present. My screen is visible, sir.
Right now it is
Yes.
visible.
Is it visible now?
Yes.
Thank you, sir. And all the presenters, I want to confirm with all of you that all the presenters would be getting their digital certificates through email with the 2 working days, and the publication will be within 7 to 8 months. And kindly, I request you all to kindly cooperate with the team of TIBS 2026. And mainly, I also want to thank our session chair, Dr. Sumit
Thank you.
Kapoor, sir, for chairing the session, and a token of appreciation to the chair on behalf of our TIBS team, the certificate, and the Global Knowledge Research Foundation and the partners. Thank you so much,
Thank you, ma'am.
everyone, for this session. It was a great session. Thank you so much.
Thank you.
Thank you very much.
Thank you.
Thank you, everyone.